All right, let's get into it. Have you ever stopped to think about how a simple on or off, a 0 or 1, can possibly create the epic games we all love? Well, that's exactly what we're going to break down. Let's jump right in. So look, you've already got the basics down. You know how to count in binary, you can flash those zeros and ones with your fingers. That part's done. But that's just the alphabet, right? The real question is, what can you build with it? What kind of worlds can you actually create?
Okay, get ready, because your next mission is officially starting now. We're leveling up from just counting, and we're diving headfirst into the world of actual game design. Think of this as your next big quest.
And here it is. Your objective, should you choose to accept it, is to complete the 80s Rockstar Maze tutorial in MakeCode Arcade. But listen, this isn't just about getting from start to finish. It's about learning the secret language that makes the whole game tick. And what do you get for completing this quest? Well, you unlock some seriously cool power-ups for your coding toolkit. We're talking about how to code game events, how to handle player movement and collisions, how to set up a game score, and even add a countdown timer. These are the essentials. Now, these aren't just random skills you're learning for fun. Every single one of these, the movement, the timer, the collisions, is a crucial building block you're going to need for your big project, designing and coding your very own digital Defender game. So yeah, this tutorial, this is your official training ground. All right, now for the really cool part. Let's pull back the curtain for a second. You're about to see how that binary knowledge you already have is secretly running this entire game from behind the scenes. First thing you need to know about is something called a tile map. The easiest way to think about it. It's like digital graph paper. It's the blueprint, the actual grid where you build your entire game world, one square at a time. And here is where it all clicks. See, in a tile map, every single one of those squares can be one of two things. Is it a path your character can walk on? The computer sees that as a 0. Is it a solid wall that blocks you? You got it, that's a 1. It's that simple, open or blocked, 0 or 1.
I mean, just think about that. Every huge, sprawling castle, every single tricky maze you've ever played, it's all built from that one super simple decision, a 0 or a 1, just repeated thousands and thousands of times. It's how we get incredible complexity out of ultimate simplicity.
And it's not just for the map. Binary tracks everything in the game. Let's say you start with 3 lives. To the game, that's the binary number 11. You take a hit from an enemy. Boom. Now you have 2 lives, and that value instantly flips to 10. It is the fastest, most efficient way for the game to keep score. So, if this simple logic can build a game world, what else can it do? Well, it turns out the exact same idea that stops your character from walking through a wall is also used to build digital fortresses in the real world. Because when you get right down to it, in cybersecurity, things are pretty black and white too. A computer system is either secure, we can call that state 1, or it's been compromised, state 0. It's either safe or it isn't, on or off. So how do you protect a network? You use a firewall. Honestly, just picture a digital bouncer at the door of a club. Its only job is to check every single piece of data that tries to get in and make sure it follows a very strict guest list. And what do these rules look like? You guessed it, they look just like our tile map rules. A cybersecurity pro might write a rule that says, hey, see any data coming from an IP address that starts with the binary pattern 110? Block it. Instantly. Don't let it in. Let's watch it in action. Okay, first IP address on the list. The number 201 in binary starts with 110. Does that match our rule? Yep. So the firewall's decision is simple. Block. Next one, 34 in binary starts with 001. No match. Decision, allow. It's that quick. A simple yes or no check, happening millions of times a second. And this is the main takeaway, right here. The logic is identical. Whether you are coding a wall in a game that says you can't pass, or a firewall on a network that says you can't pass, you are using the exact same fundamental binary principle. Now that you see just how powerful a simple 0 and 1 can be, let's bring all this back to you and the awesome game you're about to start building. So after that maze tutorial, you're going to have this amazing coding toolkit. You'll know how to build your world with a tile map, how to code movement and what happens during collisions, and how to add things like a score and a timer. So what's next? Well, maybe you could try combining those skills. What if you added a virus that actually follows your character through the maze? And really, that's the whole journey, isn't it? We started with just a single bit, a 0 or a 1, and now You have the fundamental knowledge to not only create and design your own digital worlds, but also to understand how we protect them.
So I'll just leave you with this little gem. Hopefully, after going through all this, that's one problem you won't be having anymore. Thanks for tuning in.